Okay, thank you everyone for joining us today. I'm Nick Bray from MBA. We're an architecture studio based in Victoria and here in Vancouver on these beautiful, slightly wet, but beautiful traditional territories of the Musqueam, Squamish, and Tsleil-Waututh nations. As many of you are aware, this is our second attempt at this presentation with Konasnikov. Unfortunately, the first presentation was hacked and had to be shut down. So we feel for everyone that was caught up in that, especially the presenters, and we really appreciate, we're really grateful to Devin and Iri for joining us again today. Unfortunately, we're not the only organization that's been a victim of this. There's been many kind of education providers targeted, especially ones providing free, larger scale presentations. So, as you're aware, what we've done to respond to this is we've introduced a small fee. The entire proceeds of that donation will be given to Habitat for Humanity, who are a fantastic charity. And if you're not familiar with them, I definitely recommend looking them up and supporting their work. We're preparing three more presentations before summer, all of which are topics that my firm wants to learn about. So hopefully they are relevant to your work too. Seminar 11 is on April 21st. It's about liability and protecting your practice. Many of you will know Jeff McClellan from BFL Canada Risk and Insurance Services, who will be presenting that. Seminar 12 is on May 19th and is titled Blueprint for Visibility, How to Get Your Architecture Published. And that's by Martin Knowles, owner and photographer at MK Photo Media. And then finally, Seminar 13 is on June 23rd, and it's on cyber security, which is obviously very relevant today, especially considering what we've just discussed. And it's all about protecting your firm and your work. So on to some housekeeping. We will provide as always, provide a link to the AIBC accreditation form later in the seminar. It's very easy, very simple to fill out. Just have your membership number ready. Please enter any questions that you have in the chat box. Please don't be shy. We tend to strangely not get that many questions on these seminars, so please don't be shy. Yeah, ask questions if you want to. We'll do our best to answer them at the end. And yeah, we'll provide contacts for the presenters if you want to reach out to them after the seminar as well. And finally, the full recordings, as with all the previous seminars, the recording of this seminar will be on our YouTube channel. So please feel free to check that out. So today we're going to look at how mass timber modular systems and prefabricated wall assemblies are reshaping the way we as architects think about building delivery. In particular, how offsite construction can help streamline timelines, improve quality, reduce site risk, and bring more predictability to cost, while also supporting lower carbon outcomes. So I'm really pleased to introduce our speakers. Devon Harding is a project manager and sales manager at KMT with over a decade of experience delivering modular and mass timber projects, working closely with design teams to bring these systems into place. And joining him is Iri Uthoff, an architect and construction project manager with a focus on high performance, sustainable mass timber designing and a strong background in integrated, energy conscious design approaches. So thank you very much for joining us, and over to you.
Thank you so much for the introduction, Nick, and thank you everybody for joining us. I'm going to give you a brief introduction and then I'm going to pass it on to Devon. He has a very strong engineering background and he's going to be able to dive into the technical details. So I'm sure most of you are familiar with Kolesnikov. From seedlings to solutions is basically our way of saying that we go from cradle to gate. We're one of the few manufacturing firms that are fully vertically integrated, and that will have a lot of relevance later on in our explanation of our offsite construction systems offerings. So we have been around for quite some time, more than 85 years, and the company has had a very organic evolution that has grown alongside the industry. So we started as a logging company back then in 1939. We then moved to a lumber mill, which we still own. 6 or 7 years ago, we started into the mass timber industry, and just last year we had the opportunity of opening up our newest facility, which is fully dedicated to modular and prefabricated systems that we're going to unpack later on in the presentation. So these are our three main facilities. They're all located within the West Kootenays area, 10 to 15 minutes from each other, which again helps a ton in terms of efficiencies. A sneak peek into our mass timber facility. This is where we run our main products. So we're talking about GLT, CLT, and glulam members in a wide variety of species and, of course, in a wide variety of dimensions. Something that's worth mentioning here is that all of these products are certified to use whatever we have available in terms of fiber basket. So we call it the fish of the day. Whatever is inside the sandwich is what we have access to. Although we do provide the option of selecting a visual face and, of course, the stress grade to match your structural performance requirements. That introduction, I'm going to pass it on to Devon. He's going to dive a little bit more into the FMA and why is it so important.
Thank you, Ari. So as mentioned, I'm going to go through design for manufacturing and assembly. As Ari mentioned, we have specialized and purpose-built manufacturing facilities for our value-added wood products. And what this means is we're able to add specific value to the wood fiber before it leaves our facility and make it customized to your specific project prior to it leaving site and arriving at the construction site. As you can see here, everything goes through a pretty unique path to get through our manufacturing facility. And with our specialized manufacturing equipment, it changes the way that you want to design your buildings and your projects to get the most value out of what we have to offer. We have a variety of different CLT and glulam layups that can be utilized in different projects. However, not all of them are the same. And so what we want to do is optimize the panel selection for your specific project to ensure that you're getting the most out of the fiber for what you are trying to produce. As you can see on these tables, there's a lot of different items to select on top of the visual characteristics and the species that you're going to be working with your CLT and glulam. And so when it comes to manufacturing, we have certain abilities to exceed site applied labor with the equipment that we have. And so what we want to do is explain those in great detail as to how to get the most out of the manufacturing facility. This comes down to a few different elements and key pieces of equipment that we have in our facility that add value and make your components project specific and detail them to what has been provided in the design. One thing that we'll say is most of our products are designed around a maximum length of 60 feet. Design for manufacturing and assembly somewhat leaves out the other important aspect of transportation. When you're dealing with manufactured products, you need to take into consideration the transportation cost as well, based on different load requirements. We can build our panels up to 11 foot 4 inches wide, but that does have different implications with different transportation routes and site accessibility. So we want to discuss that with our clients and make sure that they understand when they're doing a trade-off of one-time transportation cost additions versus long-term programming requirements of the building and what some of these different spans can use. Additionally, we have CNC elements that are able to integrate labor more accurately based on the model that's been provided. This allows us to help lay things out in the 3D space and execute them in the physical space with precision. That does, though, bring some understanding of how this is going to happen in terms of panel sizing and layouts. What we want to do is make sure that we design each panel to be as efficient as possible with the fewest amount of long-term cuts that are lengthwise cuts that happen on a specific panel to ensure that we are creating the most efficient panel layout. Sending the same amount of volume through the press once is a more efficient way to produce our CLT. So making sure that we are not requiring 2 smaller panels to achieve a 12-foot width is important. Here you can see that we've got different combinations and layouts of different penetrations happening on a GLT panel. And one thing to understand here is how the CNC actually works. Whenever we're able to limit our CNC work to one side of the panel, it actually increases the efficiency because that means that we have to do fewer panel flips. That has implications in terms of how these panels are delivered to site and how they're pressed, whether we're pressing the visual face or the bottom face as they're being laid out in the overall building assembly. And so understanding those pieces can help do a different project layout by optimizing the panel sizes with all of this previous information, as well as the layouts of how they're going to be used to meet the geometric shapes. Additionally, you can see that we have well over a dozen CLT layups that can be utilized, and sometimes balancing a stronger but thinner E-rated panel might be more cost effective than going with a larger volume V-rated panel. So working with all of these elements with the full breadth of manufacturing in mind really helps you to understand what kind of decisions need to be made and how to lay out the project differently. Additionally, glulam connection details is something that can sneak up on you in terms of how many combinations can be done in a specific building. This project shows, or this slide shows, different connection details that can be deployed for a column base and the different amount of times required to do a very similar connection detail. What this shows is if you have 1,000 columns in a project and you're able to save upwards of 20 minutes on each individual location, you're able to save a significant cost to the project. This is the difference in cost comes from different toolings that are applied on the CNC machine, how many times you have to change your tool as you are doing a specific connection detail, and the efficiency of that tool, how well it works to achieve that. So going through that and understanding all of those things is a critical part of making sure that you've designed something for manufacturing. This additionally, one thing that can be very helpful is coordination with several other trades with our structural assembly. We can coordinate that in the digital space and then execute it on the CNC to allow for other trades to work more quickly on site. When we're taking that into consideration, it allows different mechanical and electrical trades to evaluate where things are going to go and actually move to installation more quickly because the layouts are already established in the digital space. We also can look at each individual glulam column to beam connection and review what kind of connection is going to be most efficient, be it a locator pin or a type of screwed connection, and how those bearing connections can operate. Ari, you can take on the modular.
For sure. Sorry, I was having trouble unmuting myself. We have a few modular considerations that is worth taking into account during your design process. As Devin mentioned, our panels can be pressed up to 60 feet in length, but when we're talking about a modular approach, we do have some optimal sizing that not only takes into account how our shop is laid out, but also the transportation regulations that he just mentioned. So on that note, our optimal length would be around 40 feet. In terms of width, we would like to maximize the CLT press width, so that takes us to around 11 feet 4 inches, and that could be your maximum interior clear width, allowing you to mount the walls on the outbound of the panel. In terms of height, that is very closely tied to transportation regulations. So it depends on which route we're going to follow. That's one of the first things that we do during our design assist process is we run a transportation dry run just to identify if we have any constraints that we need to be aware of. But we have identified that a sweet spot for the height is around the 12 feet overall for the modules. And again, it becomes a balancing act between having your manufacturing efficiencies in place, maintaining your design intent, and also integrating your budget and your site logistics. It also is related to how weight is managed in these modules. Of course, that is closely related to how much mass timber is integrated in the design. So all of these factors are the main discussion points that we go through during our design assist process. With that, we have identified some early design considerations that drive efficiency up. So again, having your construction typology in mind when you start your design process is key. Having all of these DFMA principles integrated into your plans is also a key driver for efficiencies. Keeping your layouts as repeatable as possible, that allows standardization to actually shine. And most of these items might seem a little bit obvious, but in practice, when those are not laid out as your grounding principles, they can sneak up on you as well. So utility run simplifications, having economies of scale at hand, whenever you can utilize mass timber and leave it exposed, that allows you to utilize its structural potential as well as its aesthetic potential. And just keeping in mind what's your joint strategy when you're stitching not only the structural portion of your system, but also the finishes. So when all of these factors are combined during the early stages of the design, then that will allow you to have a more successful project, which takes us to our model for success highlights. So again, these are some of the key factors that we have identified in previous experiences. There needs to be a shared mindset within the project's team of shifting a good percentage of that decision making way earlier into the design process, which is very different to what a traditional construction approach is like. So again, the whole team has to be on board and understand that working with all of these prefabricated elements is a front-loaded approach, not only design-wise, but also schedule-wise, and of course, financially too. So this whole timeline is changed to having most of the decisions made during the pre-construction stage. So the ideal timeline to get your manufacturer involved is, of course, from day one, but we know that that sometimes is not realistic. So we would suggest ideally between 50% schematic design onwards. So once you have your general objectives and your general program defined, then that's when we can provide the most value to your design process, providing all of these elements that Devon just talked about. So this would be our ideal workflow, having us engaged as early as humanly possible so we can provide this DFMA input that will reflect also in your connection design. One of the things that mass timber manufacturers are best at is having a broader vision of how to integrate all of the other disciplines and how to collaboratively work with all of the trades to make their life easier on site, right? In terms of the digital realm, we all know that BIM isn't an option anymore. So especially when you're treating your project as a compilation of systems, there's a high level of coordination that needs to happen within disciplines, and having all within a confederated model helps you do that. So in terms of our process, we do model everything in-house to a very high level of detail. So we're talking about LOD 400 upwards, and that allows us to be able to identify any potential value engineering options and to make sure that all of the parts are interacting within each other properly. And we do that not only for a modular approach, but for all of the other components that we're able to manufacture, including the panelized systems as well. This is a real life example of how our 3D model compares to a project on site and how we can make the most value out of it. So understanding how to manage your prefabrication scope is also going to provide you the most efficiencies. Not all projects are made for a fully volumetric modular approach. So usually what makes the most sense is to combine modular and panelized where it makes the most sense. In our particular case, we have quite some flexibility for manufacturing different systems. So if we're talking about prefabricated walls, we can either use CLT as a structural base or light frame. And then where it makes sense, integrate all of that into fully volumetric modular units. And when all of this is implemented correctly, and by that I mean having your key players involved way early on during the design process, then you can achieve the promise that prefabricated systems can deliver, right? And we're talking about mainly a 30 to 50% faster delivery, 10 to 20% lower costs material-wise, tighter tolerances that come from a very highly automated manufacturing process, and up to 60% in waste reduction. So I'm going to pass it on to Devon for the prefabricated walls.
So with prefabricated walls, we have two different offerings, and we'll go through a few details on both, but we offer both a light wood frame and a CLT base as the walls, as well as various different optional pricing and services in terms of weather barriers, insulation, and other integrations, all the way up to exterior cladding on some projects when the layout is or when the design is adequate. One thing is that we have a very adaptable system. So it's been designed to allow us to integrate several different wall assembly details to meet the project's requirements rather than having a prescriptive wall assembly requirement. The piece of equipment that you see here is called a Technowood wall line. And it has several of those elements that I discussed earlier in terms of manufacturing capabilities to bring those industrialized practices to your construction projects. You'll see the various locations along the panel layout that show different layouts. Those all translate to a digital layout in our modeling software, ensuring that everything is done effectively. Additionally, you can see that we have overhead cranes as well as panel flipping equipment to allow these panels to be worked on from both sides as required to meet the assemblies. And the last thing that that system does is it actually has a nailing and wall trimming gantry system that allows us to ensure every opening and panel is built to the exact specifications required by the project, not only to the dimensions, but things like fastener layouts and spacings to meet these engineering requirements. With that, we're able to create a wide range of prefabricated wall panel systems that can be delivered to site with a number of different elements integrated into these panels. You can see here where we have windows integrated into these panels, as well as drywall to ensure that the fire rating behind some of the pre-installed structural elements will be achieved with the final building. We can also work to include various different types of exterior membranes and insulation to make the meet the project's thermal requirements. You can see here panel layouts can be broken down into different sizes based on the project specific requirements. So when we look at how we're going to produce each panel, will not only consider the manufacturing efficiency, but the transportation, logistics, and installation considerations to make sure that we're getting the most value out of what's being offered. Again, we have specialized equipment to allow us to do things like window installations, and we're working at ground height when we're doing a lot of this execution, which makes it a safer work environment rather than having to work off of lifts on site when you're dealing with heavy windows. Oftentimes, tower cranes are used to install other elements, and so you can repurpose those to work with your wall panel system. Again, this is something that's brought into consideration during the initial design stage to make sure that panel weights are in line with what piece of crane and its reaches will be required. And you can see here, we'll start to look at weatherization and how to make sure that we're properly protecting the different wall systems and floor systems before they're brought to site. Here's a unique element on this specific project where it had the raked walls. That is an element that's worth discussing in that it's less efficient to manufacture, but creates the programming space that was required by this specific project. And we were able to produce it because of the amount of time that it would have taken on site was actually greater than what would have been provided to do in the facility. So with this, repeatability is going to be a key element. What we want to do is create a large stock of repeated components, and then we can standardize that production. We are then able to use manufacturing practices to get more value out of each component that we manufacture, utilizing jigs and other elements to hold things in place and create a more efficient structure overall. Again, we'll be coordinating with both mechanical and electrical trades to ensure that as we go through the different layouts, we are incorporating penetrations and other allowances to ensure that they are going to be laid out effectively and meet the project specific installation requirements, planning for both what's going to be happening in the facility as well as on site to create the aesthetic and the open exposed mass timber elements as required. This one shows how we can integrate different elements into a single project to ensure that we're using the right material for the right location. Sometimes a CLT wall might be effective on one side, but a light wood frame might be more effective for hiding some plumbing chases and things like that. So we can utilize those different wall assemblies within the same project and make sure that we're achieving the needs of the project. Again, having the two different substrates for our wall assembly allows us to integrate different acoustic partitions and assemblies. There are several tested and listed wall assemblies and acoustic performance assemblies that can be utilized. And what we'll work with during the initial design consultation and discussion is establishing what's going to be the right balance between what can be applied in the manufacturing facility versus in the field for different wall and acoustic performance pieces. Here's an example where we installed the acoustics to the roof to achieve what they were looking for, as well as the floor, and then left the mass timber exposed. We can also apply exterior insulation in between CLT panels to ensure that we have the appropriate acoustic and fire rating for that specific project. And we'll work with the architect of record to establish what is the best wall assembly for that specific project. Moisture mitigation is something that needs to be considered as we're doing any mass timber or any prefabricated project, because we are creating a finished product and sending that to site for integration into the project. So we have several stages. We'll have the pre-transportation prepping. So we'll wrap all of our glulam and CLT products before going on to the truck. Additionally, when you're dealing with modular construction, sometimes a temporary shipping membrane as well as shrink wrap should be applied before it gets delivered. This ensures that you're protecting that finished look with a proper system that can be removed on site prior to installation or at the right time with installation. Sometimes you can leave some of the elements in place to ensure that during construction until the final roof is installed, they're still being protected. You can see here that temporary roof membrane being applied to the top of the membrane, to the top of the module, as well as the final air vapor barrier system on the outside to create a weather tight module that's waiting for final completion of that roof system. Scope delineation is key for that. What's going to be happening in the facility versus on site. Obviously, with a CLT panel, there's a lot of surface area that would need to be covered on site. So integrating that into the facility in the facility and having a roll of additional wet guard to cover the spline locations allows these panels to be protected throughout construction. But different sites require different levels of moisture management. Sometimes seam tape is all that's required to prevent water from getting through to the visual face. So we always encourage to work with the installers and the general contractors to understand a comprehensive moisture management system, not just what will be applied in the facility, but what's going to be applied on site, and how it's going to be removed, and then the overall performance and protection that's going to be provided there. In terms of speed of installation, it really comes down to how the walls are panelized and laid out. We've seen a number of different successful CLT floor plate installations of 8,000 to 10,000 square feet of installation a day, and then an equivalent amount of light wood frame walls be installed in the subsequent 2 to 3 days, and then in some instances, even a 2 floors per week installation rate. It comes down to availability of crane on site and number of workers that will be there to do these installation, as well as fastening details. So all of those things, installation schedule allows a lot more performance with fewer people actually on site to ensure a safer work environment. As Ari showed earlier, there is all of these elements being modeled for final installation on site. So we are confident in the way we've produced everything with consideration of final site conditions to be delivered, and that allows modules to be placed in a more efficient manner. We've seen installations happen of as many 20 modules a day, and this is attributed to the CNC and precision of the manufacturing, but also the top-mounted connection details that reduces the amount of time the installers need to be dealing with straps. And so this allows projects in remote locations and in adverse weather conditions to be installed very quickly and with high efficiency. Additionally, with the CNC and other equipment that we use in the facility, we have the confidence that everything will line up with what's been designed in the digital space and line up with what will be produced on site, with some obvious precautions being taken to ensure that site conditions are being made to the design and translated back to what we've produced. But this allows us to overlap the manufacturing with what's happening on site and reduce the overall project schedule by 30 to 50%, which can be very advantageous, especially to places where you want to start getting a return on investment right away, reducing your general conditions costs and other elements like that.
Okay, so just to wrap it up, scalability and hybridization. So these are two principles that we strongly advise including during your design process. The more repeatable your layout is, the more efficient it's going to be for us to manufacture, and the higher potential it's going to have to be replicable in different projects down the pipeline. And of course, we are pushing to get the most of each system, which means that its implementation should be understood correctly. So how can you make the most of the mass timber properties in terms of structural performance, and how is it best to combine it with traditional systems such as concrete and steel to make the most of both worlds? And of course, then you have a very cost-efficient biophilic final result. And we just wanted to show you a couple pictures of a fully completed workforce housing building in Montana that integrated a modular approach as well as a panelized approach for the circulation and common spaces. So again, this was delivered with a very tight budget as expected in a workforce housing building. But the difference is that the end result was considerably better than any other construction approach. So the possibilities are endless as long as the systems are implemented properly. Yeah, Devin, any final words?
I think there's a couple of questions in the chat.
Yeah, absolutely. Well, thank you very much for this presentation. That was really, really interesting. I think we can have a conversation now, and I do encourage those of you listening to ask any questions at this point. Put them in the chat box. We do have a question here from Juliana to start with. What is the tolerance to moisture, especially considering a rainy city as Vancouver during installation?
So there's tolerance to moisture is kind of a hard thing to define, but one thing that we can say is mass timber has been highly adopted in the Pacific Northwest of the United States and as well as the lower mainland of Vancouver and Vancouver Island, sorry, with appropriate moisture mitigation plans. So this can be installed in several different weather conditions. Winds sometimes impact your ability to crane, but in terms of managing the moisture, because we're end sealing our boards before they go into the different panels, we're able to better control the humidity and changing in fluctuation. And then as part of any appropriate moisture management plan, there will be the storage in the facility, there will be storage on site, as well as when to remove any temporary protection before putting on permanent roofing. And then the last piece is how to dry out the building and ensure you hit that moisture content or that moisture stability of the building to ensure the stability of all your different elements. So there's a few different ways to address it, but there are several professionals in the area that can help ensure that the moisture is being appropriately taken care of.
Yeah, fantastic. And one of the things we've spoken about before was, we've seen some mass timber buildings where they have the balconies as an extension of the CRT floor plates. And you I remember having a discussion about the potential problems with moisture with regards to and also sort of temperature with regards to panels or especially floor panels going from inside to outside. I wondered if you could just comment on that.
Obviously, thermal bridging is something that gets brought to mind, but typically what you want is a properly sloped deck that's slightly lower than the door threshold that you're going from one space to the next. And so you just need to have some consideration in terms of how you're going to detail those elements in that continual floor plate transition to ensure that you've got the appropriate water shedding and you're not going to be creating a pool at any of the wall elements. So there are ways to do that, and so it's good to understand what performance trade-offs or risks should be considered as you're looking at detailing it that way.
Thank you. So we've got a question here from Jin. How do you compare glulam panel versus dowel laminated panel in building construction? Can you talk more about the glue used in the product and the life cycle of glulam panels?
So glue laminated and dowel laminated panels are fairly similar in concept from a structural capacity. They both have a major strength direction, where all the panels or all the elements are stacked vertically and then pressed together widthwise before they're laid across a span. There's different ways to evaluate the systems. Glue laminated has different shear capacities compared to dowel laminated, and so that each one has its space that is a good way to be used. In terms of glue, we have some specifications, but it's a low VOC glue that's utilized, and it's a very, very small portion of the overall structural assembly that is actually made up of glue. Primarily, we're relying on the wood to achieve the strength and that we're needing to provide. And we do provide those as a specific cut sheet in each project before it is delivered to ensure everybody understands what is being integrated into the project.
Great. Ryan asks, what building types do you focus on? Multifamily, obviously, but any sort of other building typologies, healthcare, commercial, single family?
This is a really unique answer where we've set ourselves up in such a way that allows us to be very, very flexible in terms of how our product is deployed. We have some groups ordering billet assemblies to utilize in saunas, in single room saunas. And we also have projects where we're doing fully fabricated mass timber elements up to 10-story office buildings. So that we have great examples of almost every different use case, from industrial to commercial to single and multifamily residential, for our building types. So there's really no limit in terms of where we operate. It's mainly about achieving the structural conformance to what's being done. There are some considerations when it comes to healthcare for certain jurisdictions in terms of how that can be applied, but for the most part, we have quite a few examples in each individual classification of building.
Thank you. I mean, I guess it brings me on to one of my questions, because I'm sure a lot of people here have been in the same situation. I don't know how many times I've tried to sell the idea of mass timber to clients, especially those that normally build in developers that normally build in concrete. Yeah, and I typically bring up the speed of construction and the reduction in costly construction errors. Have you got any tips that will help us architects trying to persuade clients to at least investigate mass timber, if not move forward with it?
I think one thing to understand is that there are so many great examples of every different building typology that have already been done, but maybe not in your region. So reaching out to us and allowing us to discuss how to lay out your grid lines, that's what's going to specify your CLT and your glulam sizes and the overall volume of mass timber and the efficiency of the structural system is incredibly important. Different clients want to engage it different ways, but it's not easy to do a layout for a concrete or steel building and then just check it against what a mass timber building would be, because it's a different layout and it's not laid out properly for the efficiencies of mass timber and getting the most out of that. So effectively engaging with a structural engineer who can help guide the grid line layouts to optimize for a mass timber facility or mass timber building is going to be important to do very early. And this can be done in a very efficient way. It can be as simple as some markups on a 50% SD drawing, or even earlier on a schematic drawing, just to say, here is what we would intend to use as a mass timber system and what grid line implications there might be at a very, very early stage. And so that's a really good way to make sure that you're having your project set up for success early.
Right. Is there any particular typologies or sizes or scales or anything that you're finding stack up better against more traditional construction methods? Is there I don't know, a 10-story apartment building, whatever it is there something you're having particular luck with?
So there's a few different, because there's different hybrid systems that we work with. CLT over light frame is really effective up to 6 stories. And then we see a lot of CLT over glulam post and beams in the 6 to 12 stories and even beyond. We've done a couple of projects up above 12 stories that are CLT that are point supported. But that's just in the housing, student housing type and office space. We've seen a lot of different unique applications of mass timber for recreation centers to create some of those long span beams over top of swimming pools and things like that. And so there's a lot of different solutions that can be utilized to achieve the spans and the aesthetic that you're looking for with mass timber for the final building programming and performance. So I wouldn't say that there's many limitations. It's about understanding the system and understanding the client's desires to utilize prefabrication, the biophilic benefits of mass timber, the reduced carbon emissions and things like that. And then how do we integrate those into the project so that they get the building that they want while getting the most out of the manufacturing expertise that we have to offer.
Fantastic. Jeremiah asks, well, firstly, he says the Montana Workforce Project is beautiful. I agree. He's curious if there was a cost comparison completed between CLT modular used and stick frame modular, and what would that premium be for CLT?
We don't have direct access to that, but what we can say is that the developer that we worked with has done light frame modular projects in advance of this one that they did with us. And so they were able to find value going to the mass timber system. The concept is we are able to utilize CNC for a little bit more efficient execution in our facility, reduce the amount of labor in a CLT wall compared to a light frame wall. So the ultimate costs are marginal differences between a light wood frame and a CLT module project.
It's great to hear. Shahab asks, can you please walk through the specifications as well? What type of building could we work with? Talk about the fire-rated systems that allow for this material and about this material on a sprinkler systems building. And Ernst actually asked about the fire rating and fire separations as well. So maybe we could get a little bit technical about fire ratings. I'm sure someone else is going to ask about acoustics as well. So maybe we could talk about some of the assemblies here and how they work.
I mean that becomes a talk on all on its own. So all of this is codified in terms of how the fire rating is achieved. So you can use encapsulation or you can use the char rating of your mass timber to achieve your fire rating, depending on how tall you're building and in what jurisdiction. So there's different ways to achieve that depending on what the ultimate solution is. But I can say that there are resources out there. Woodworks has a lot of great resources in terms of how to, different assemblies that you can utilize, as well as how to approach your specific building, depending on the classification of building and type, jurisdiction, things like that, to achieve what you're looking to use. But ultimately, it's typically comes down to the fire rating through encapsulation or the charring of the mass timber, because mass timber is a self-extinguishing material. Once the accelerants in the room are extinguished, the mass timber itself will self-extinguish, and it then the structural capacity left in that piece of material, because you can measure the depth of char and how much remaining structure is left.
Great. I mean, we can talk more about that later, maybe. But let's work through some of these questions. May is asking, or sort of questioning, delivering the LOD 400 BIM model will require significant software expertise on behalf of the consultants. Does this translate into higher consultant fees compared to normal construction methods?
It depends on how you structure the contract and who's taking on what scopes of work. A coordinated model is becoming more and more commonplace in all types of construction. So we're often working with general contractors to have a coordinated model between multiple trades to ensure that they're all talking to each other appropriately. On a mass timber building, often there's an interface with the structural steel, and so we have to have a very precise model coordination to ensure that any connections that are happening between the two elements are going to come together on site within the tolerances of the design. So I can't speak specifically to the architectural or the design consultant costs, but what it does mean is that the manufacturers and suppliers engaged will be coordinating with each other a little bit more. And it should indicate that means and methods need to be reconsidered in terms of laying out of different elements. If you're going to specify an HRV, for example, you need to understand the different duct routing, ensure that there's not going to be any crosses that would then lower your ceiling space. So nothing that isn't commonplace in construction. It's about having that happen earlier and in the digital space to ensure that we're not making changes to the manufacturing once it's begun.
Well, I guess what's even more difficult, in terms of figuring out the costs of this to analyze is the savings relating to this, right? By having all of this so heavily resolved before going to construction. Obviously there's enormous cost savings in reduction of construction errors, and also in terms of consultant time during construction as well. So, I mean, how in depth can you get into those cost comparisons? Are you finding that you're able to do some comparison there, or is it literally just project by project?
Yeah, we can't compare because as you said, it reduces rework, it reduces change orders. So we'd have to be doing a post uh, project analysis of two different projects, and nobody's going to build the same project twice in two different construction methodologies to actually establish what the cost differences are. But what we can say is it's cheaper to change it digitally than it is to change it physically. So working through that in the digital space pays off 9 times out of 10.
Absolutely. John asked, one of your diagrams showed a shorter design phase. Actually, this is relevant as well. Does this diagram assume that you would be on board at the design assist role? I think you already talked a little about that, but it'd be great to discuss that further. He also says, if not, could you comment on the reason for the short design timeline on this diagram?
So yes, it is assuming that we'd be involved as the design assist stage. One thing is that mass timber has gotten to a point now where designs are advancing quite far and then able to be tendered by multiple groups. But you're losing any manufacturer specific advantages in that case. So it depends on how you're doing your design and what stage you're bringing on um, your manufacturer. Also, it does change from jurisdiction to jurisdiction when you're working through different building permit and development permit applications. But we've completed over 400 mass timber projects, and so we are able to help evaluate and come up with connection details and design schemes that will work most efficiently and reduce the overall design timeline by utilizing our experience in terms of other projects we've completed.
Fantastic. This is an interesting question. Another one from Juliana. Going back to the moisture tolerance, what happens to mass timber when there's a leak in the building?
That also depends on how the project is laid out. In terms of our temporary membranes or our membranes being installed permanently to help address that, and is there a method for the water to essentially escape or dry out if there is a leak in the building. So if there's a persistent leak that is undiscoverable, is a different response than a one-time leak that is addressed and mitigated with adequate drying. Difficult to answer which one to the scenario without knowing a few more details. But those are the kind of, if you have a persistent leak that nobody knows about, you'd have an issue with any type of building typology.
Well, then, another one from Sean, expanding on his previous question about the cost comparison. Wouldn't the CRT option utilize far more materials and resources than the lightwood framed option, which of course it does. But I guess the question is, how does that weigh into the whole comparison with stick framing?
So because you're utilizing it as your finished element as well, it helps reduce the overall number of elements being brought into the project. So having a CLT finish wall is going to be to remove your drywall requirements and things like that. And as again, we're able to use the CNC to reduce the amount of labor to deploy. So it is technically more material, but because we have specialized equipment that allows us to do it, the resources from a human resources perspective actually is reduced on a CLT wall because we're utilizing the CNC more, we're utilizing the press more, and we're reducing scopes such as drywall, priming, and other things. Whereas with CLT, you do two to three coats of finisher, and you're completing the finish.
Thank you. I do have a question about acoustics. I mean, my office, we do a lot of apartment buildings. Yeah, we've worked with you, discussed with you, your sort of multiple different acoustic solutions. We all, I mean, I think everyone here probably loves the idea of working in mass timber. You don't have to sell it to us, but acoustics is a concern here, isn't it? When compared with concrete, or even stick frame with acoustic insulation. Maybe you could talk a little to that point.
So panel breaks are going to be an important piece. So ultimately understanding the material and what it's susceptible to and where it performs well. It's a lower density material compared to steel and concrete. So understanding the frequencies that are going to move through it and how they're going to potentially flank through the structural system compared to reverberate sound is an important piece. We work with a number of great acoustic consultants that kind of take the charge in terms of how to approach it. But one thing that we do is we look at the structural system, see where we can apply structural breaks to reduce flanking of the acoustics, as well as how can we pre-install different acoustic materials into the modules or panelized wall systems in the facility. So utilizing some mineral wool on the exterior of the wall between two modules, as well as doing a surface treatment to the CLT also can help. You can see in this project, it's the carpet. There's also an acoustic treatment underneath the carpet, as well as the ceiling clouds that are being utilized to help adjust or account for some of the acoustic performance.
So I'd imagine you find it's quite a dead noise in there naturally anyway, isn't it? Obviously, I mean, we're talking about acoustics between rooms or between units, but the sound itself in those spaces, maybe you could describe that slightly. Would it be quite a dead sound?
Once you've applied the acoustic toppings, yeah. So it's like most construction types. If you're in an empty room, it's going to be worse than once you've got it furnished and have the wall finishing, floor finishing, and ceiling finishings as required. So we have different solutions to different project types. How big is the open space? What type of sound levels are you going to be experiencing? We've done some great mass timber schools that have some good acoustic practices or principles being applied to them through various treatments and panel breaks as well. So it depends on when you're evaluating it, but we've got a lot of great groups that have different products that can be applied to ensure that you're getting the acoustic performance you need.
Brilliant. I think we've got time for one last question here. It's a good one. Is it true that the cost of maintaining this type of building is much higher than its construction costs after 8 years? It's very specific.
Yeah, I've not heard that one. It would come down to a lot of different elements that would need to be considered in terms of thermal performance and what you're comparing it to. So is this in terms of operating costs? Is it in terms of specific maintenance costs? Is it in terms of insurance? I'm not clear on that, but I don't have anything on that specific question.
I guess it's more about is how does it compare in terms of maintenance cost relative to other construction types? I think that might be a better question.
Again, the CLT is going to be a more durable surface that you're going to see compared to something like drywall. So you'll have fewer incidents where things are being damaged. However, it's good to each finish has a maintenance program that should be followed. So it's again similar to that. So is there a significant cost between doing touch-up paint on a drywall wall versus resealing a CLT wall? I'm not sure. I think that's something that would be actually more for an owner developer that could be discussed. But what we can say is that we have developers that are on there that have done multiple iterations of mass timber buildings and found it to be more beneficial on a long-term stage. An example is when you're doing a CLT over light frame wall project, you'll get fewer nail pops and have more plumb walls because you're actually utilizing a manufactured product at each floor to reestablish level and squareness. So there's different pluses and minuses for any building typology. So it's hard to say a definitive yes or no on that.
Brilliant, brilliant. Well, that brings us up to the hour. Like, thank you so much again. I don't know if you've got a slide with some sort of contact information on where people can reach out to you if they have further questions. Otherwise, I'm sure they can search for you. We've just put up the AIBC link as well. If you just don't forget to fill out that form to get your CPT points. But I just want to say a huge thank you to Devin and Iri for coming back and joining us again and giving such a fantastic presentation. Thank you so much, and thank you again to the volunteers in my office that have taken their time to administrate and put together this session. Thanks for joining us. Yeah, hopefully we'll see you again soon. Take care.
So
Thank you
much.
for your time.
Bye bye.